right, so let's take a look at Unit 5 review. Now, the first question wants us to algebraically solve the following system. All right, so we know the first step is that we need to get one of the variables by itself in one of these two equations. Okay, so we could clearly see that this bottom equation is clearly easier to get one of the variables by itself. And I want to point out it does not matter whether you get the x by itself or the y by itself. That is completely up to you. Okay, so I think I'm going to get the x by itself. Okay, so if I want to get the x by itself, what I'm going to do is I'm going to subtract the y, and I'm going to add the 1 to both sides of the equation. So I'm subtracting the y and adding the 1. That way the y's cancel out and the 1's cancel out, leaving me with x equals. Now you could write this as negative y plus 1, or if you prefer to write 1 minus y, that's okay as well. But since x is equal to this expression right here, we can take this expression and substitute it where we see the x in this first equation. Okay, so again, since x is equal to this, I'm going to take this and put it where I see the x in the first equation. Okay, so that's all I did. I took the negative y plus 1 and I put it where this x was. And then I just brought the rest of the equation down. Now, I know when something is squared, it means we have two of them, so we're going to write this out twice. But before we do, you don't want to have to triple distribute, right? You don't want to have to multiply 3 terms by 3 terms. So let's first combine our like terms. Okay, so I can combine the positive 1 and the negative 2. So 1 minus 2 is just negative 1. So I'm going to rewrite this parenthesis as negative y minus 1. Okay, and then I'll bring everything else down. Oop. Okay, now, we already said that this squared, right? Please don't try to distribute a square into each individual term in the parenthesis. A square means that we have two of these. So we are going to take this and write it out twice. And same thing over here, right? We have y minus 3 squared, so it means we have 2 y minus 3's being multiplied together. All right, and let's distribute. So negative y times negative y would be positive y squared. Negative y times negative 1 is positive y. Negative 1 times negative y is another positive y. And negative 1 times negative 1 is positive 1. Right, then I'm going to bring this plus sign down and let's keep distributing. Y times y is y squared. Y times negative 3 is negative 3y. Negative 3 times y is negative 3y. And negative 3 times negative 3 is positive 9. All right, and we're going to bring down the equal 16. Now, I know I have to combine like terms over here, and I also have to get this side of the equation set equal to 0. So why don't we do that all at once? Let's subtract the 16 from both sides of the equation. That way the right side of the equation equals 0. And when I combine my like terms, y squared plus y squared would be 2y squared. All right, we have a positive y, a negative 3y, and a negative 3y. So let's see, if we have negative 6y, and we want to add 2y to that, that would be negative 4y. Okay, and then our numbers, we have, let's see, a 1 plus 9, which is 10, and 10 minus 16 is negative 6. All right, what worked out nicely here is these are all even, right? So if they're all even, why don't we just divide both sides of the equation by 2? You could show you're doing that, or you could just do it. Like if you want to write divided by 2 and divided by 2, you can. Or if you just want to just jump right into it and just divide all these by 2, go for it. So that leaves us with y squared minus 2y minus 3, and then equals 0. All right, so let's factor and then solve for y. All right, so since there's a 1 in front of our first term, we set up 2 sets of parentheses, and we're going to put a y in the first spot in each parenthesis because y times y gives us y squared. And then from here, we just have to come up with, this is the AM method, so 2 numbers that add to negative 2 and multiply to negative 3. So negative 3 and positive 1. All right, so we wind up with y equals 3 and y equals negative 1. Now, we need to figure out what x values correspond with these y values. So let's go back up to the original equation. Actually, I'm not even going to use the original equation. I'm going to use this equation. Since we're solving for x, we might as well use the equation where x is by itself. So x is equal to negative y plus 1. So x is equal to, let me just write it first. X equals negative y plus 1. Okay, so x equals negative, well, let's plug this y value of a 3 in, so negative 3 plus 1. And since negative 3 plus 1 is negative 2, we wind up getting an x value of negative 2 that corresponds to the y value of 3. Now, we always want to write these as coordinates, but remember, when you write a coordinate, it goes x, comma, y. So please don't write 3, comma, negative 2. It's negative 2, comma, 3. Now, if I were to write it like this, what is wrong with the way I wrote that coordinate? Parentheses, right? You need parentheses around a coordinate, so don't forget that. Okay, so let's come over here. So again, we're using the equation x equals negative y plus 1. So x equals, well, isn't a negative 1 positive 1? So we have positive 1, and then we can bring down the plus 1. And since 1 plus 1 is 2, we get x equals 2. So an x value of 2 corresponds with the y value of negative 1. And again, remember, it's always x and then y, x comma y. So it's going to be 2, comma, negative 1. Now, I always like to make sure my answers check out. So what I like to do is I like to take these answers right here, okay, take each coordinate and go back up to the original problem. So you always check in an original. And you could take your first coordinate, which was negative 2, 3, and you could substitute negative 2 in for x and 3 in for y and make sure this equation checks out. Now you want to also make sure it checks out in this equation. Okay, if it does, then check your second coordinate, and if they both check, then you know you have the right answer. Now, one thing I want to point out, I was just checking and I noticed that this first coordinate checked and this one didn't. And you want to know why? Let's look back down here. Because look at that. I copied it wrong. It was 2, negative 1. So that's why it's important to check. Okay, I forgot to carry over the negative in my final answer box there. So please always make sure you check your answers. Okay, number 2. Well, they want to know for which values of x will the left side of the equation equal the right side of the equation. Now, could you substitute these in for x and see what checks? Yeah, you totally could. And remember, they're not going to check exactly because these are rounded solutions. But in my opinion, the easiest way to get the answer is to take the left side of the equation right here and plug that into y1 in your calculator, and then take the right side of the equation and plug that into y2 in your calculator. And then we're just going to do second, trace, intersect. Okay, so we first need to plug this left side of the equation into y1. Now, if you forget how to plug in the absolute value bars, what we do is we go to math, and we go over to NUM, and look at that, it's the first one, so you could hit enter on that. And then I'm just going to plug in x squared minus 9, and then I'm going to go outside the absolute value bars and plug in minus 3. Okay, so now under y2, we are going to plug in the right side of the equation. Now, if you forget how to get that little base, remember, we go to math for that too. So you can go to math. And I find it faster to scroll up than down, but if you scroll up, letter A is log base. And so we're going to make that little base of 3, and then within the parenthesis, we're going to put an x. All right, I don't know what my window's set up as, so I'm going to hit zoom 6, just so it makes it a regular, negative 10 to positive 10 screen. All right, so we could see that there are 2 points of intersection. All right, so let's find this one first. So if you remember the steps, we hit second, trace, and then we're going to choose the number 5, which is intersect. So I'm hitting number 5. Okay, now all I'm going to do is I'm going to use, I don't really see the cursor. See how it says it's at 0, 6? Oh, there it is, 0, 6. I don't know why I didn't see that. But I'm going to move it over until I get somewhere near that point of intersection. So I'm hitting my right arrow, okay? And you don't have to get right on it, but you want to get close to it. And when you're near it, you're going to hit enter, enter, enter. Now, they give us the coordinate of the point of intersection. But the thing is, first of all, they tell us x values. But if you look at this equation, aren't there only x values in there? So the first one would be at 2.29. So I'm assuming choice 1 is the answer because that's the only one that has that. But let's make sure that this other point of intersection occurs at 3.63. So again, we're going to do second, trace, and then you're going to go, I just hit the number 5. I feel like it's kind of a waste of time to scroll all the way down and hit enter. So you could just hit the 5. And then we use our arrow key to go over to the next one and just hit enter, enter, enter. And remember, to move over, you're using the left and right arrow keys, not the up and down. The up and down, well, look what happens. Well, you're not really going to see here, but up and down just switches it from one curve to the next. So here, if I come off that, you'll see, up and down just moves it from one curve to the next. So we're just using our left and right arrow keys to actually move that cursor. Okay, so let's hit enter, 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 and oh, look at that. The other one is at 3.63. So choice 1 is going to be our answer. Okay, so number 3, it looks like we have 2 companies comparing 2 plans for speeding up its technical support time. Okay, so plan A is given by this function and plan B is given by this function. And what they want us to do is they want us to graph A of x and B of x on this set of axes below. Okay, so why don't we, in our calculator, go to y1 and substitute, plug in this equation, and then go to y2 and plug in this equation. Okay, so that's what I did. Now, if I were to hit graph, my window is still set from a -10 to a +10 like the last screen, so I don't know how much I'm going to see. Because look, they want us to graph from 0 to 100. And if I look, let me see if I can move this over. There we go. If I look here, I'm going to set my window to match theirs. So if we look, my x minimum would be 0 and my x maximum would be 100. So let's hit window. Okay, x minimum, I'm going to make 0. Oops, sorry, my iPad blocks this every time I type it in. And my x maximum is going to be 100. And then I could see here my y minimum is 0 and my y maximum is 20. So my y minimum would be 0 and my y maximum would be 20. So now if I hit graph, I can see the graph. But we're going to need to go to the table of values to figure out exactly where to plot these points. So if you look along the x-axis, you don't have to plot every point. Like, see how they only numbered 10, 20, 30? You can just plot the points that occur at every, 10 units. So if in your calculator, if you go to second window, right, the table set, instead of jumping by 1s, you can jump by 10s, and then you don't have to scroll all the way to 100 in your table. So now if we go to our table of values, let me start this at 0 though. So now if we go to our table of values, look at that, they're jumping by 10s, not by 20. So it's not going to be as far to scroll. Okay, so take a minute, hit pause, and plot all these points. Okay, so as you're plotting these, please make sure. See, my points, they're not going to be exact. Like this point didn't even hit the curve, but I didn't make my curve go up and then come back down. I tried my best to make one smooth, flowy curve. I didn't move the pen up and down. I just had to go as smooth as possible. Notice I labeled, and I did not use arrows, okay? Please don't use arrows because they say here to graph in this interval only. They don't want you to graph outside of it, and the arrows would imply that, you would keep going outside of it. Okay. Now it says down here, to the nearest integer, solve the equation when does a of x equal b of x. So they're looking for us to do, we could solve this algebraically, but it doesn't say algebraically. I'll do it both ways. But we could do what we did in the last example. Since we have our graph here, we could do second, trace, intersect, and look at where our graphs intersect. All right. So honestly, I would really recommend doing it that way. I wouldn't even bother doing it algebraically because they did, have you graph this for a reason. Okay, so I'm going back to my graphs, and now I'm going to hit, if we want to know when one function equals another, we're looking for the intersect. So second, trace, and then choice 5. Okay, so we're going to move the cursor near the point of intersection. And remember, we just hit enter 3 times. You hit it until it actually says the word intersection down here. Now remember, we're concerned with the x coordinate only, and I believe they wanted us to, the x value only, and they wanted us to round to the nearest integer, so wouldn't that be 35? And even if I look at my graph here, it does appear that 35 is where they're going to intersect. So here we could just say 35, I guess, customer service representatives. That would be my units. Okay, I mean, I wrote out the whole thing. Since there's more than one part to this question, I wanted to clarify what I was answering. So A of x equals B of x when there are 35 customer service representatives. Okay, that's what the x values represent. Okay, so I just kind of covered my work. For those of you that prefer to do it algebraically, I just said A of x equal to B of x. And then I decided to divide. You could divide by either 15.7 or 11. That's up to you. If you don't like to do it algebraically, you can just ignore this part. Right? I decided to divide by 11, leaving me with 15.7 over 11 times this equals, and then those cancel, so 0.99 to the x power. Now I knew I had to get both of these on one side of the equation, and since I moved my numbers over here, I decided to move the terms of the exponent to the right side of the equation. So I divided both sides by 0.98 to the x power. So what happens is, on the left side, I'm left with this fraction, and on the right side, I could leave this as 0.99 over 0.98 to the x power. I put it all into one fraction. Now, if you're solving for an exponent, we use logs. So again, I'm going through this quickly because I don't recommend this is the way to do it, but it's up to you. So if we put log in front of both sides of the equation, what's going to happen is this x comes to the front of the word log. And to solve for x, we just divide both sides by log of this fraction. So when you do, you're just going to plug all of this into your calculator, and guess what you end up with? The same exact thing. X equals 35. Okay, the last part of the question wants us to determine to the nearest minute what B of 100 minus A of 100 is equal to. Okay, so by looking at the table of values, we could see that, right, this was B of x. So for B of 100, it's equal to approximately 4.0264, right, that's rounded. And for A of 100, it's equal to approximately, I don't know why I wrote equals. That right there? Let me erase that. There we go, minus. We know that A of 100 would be right here. So it would be approximately 2.0821. And if we subtract those, that is, I'm going to have you seen this symbol? This is approximately 1.9. But they want it to the nearest minute, so that would round to 2 minutes. Now, they want us to explain what that means in the context of this problem. Okay, so basically, if we plug 100 in for the x, now think, the x means the number of customer service representatives. So when there are 100 customer service representatives, the difference in the average wait time would be 2 minutes, right? Because the y value represents the average wait time. Okay, so you could just write that out. I'm going to box that off because that's also an answer. So when there are 100 customer service representatives, the difference in the average wait time is 2 minutes. Okay, so it looks like in number 4 we have a system where we have 3 equations in 3 variables. All right, now the first thing we want to do is, if you notice, these equations aren't, see how this equation goes A, B, C, and then equals a number? A, B, C equals a number. Well, we need to first rearrange this equation. What we need to do is, see this A that's on the right-hand side of the equation? We need to move it over here on the left side of the equation. We need to put it in the front. I mean, you could just take it and move it. Think about it. If there's an A on this side of the equation, on the right side of the equation, if we move it to the left, doesn't it just become a negative A? Okay, so again, all I did was I took this A and moved it in front of the 6B and made it negative, okay? So then all we were left with on the right side of the equation is 14. So I'm going to just cross this off because we no longer need this. All right, so now we have 3 equations all set up in the same order. So what I like to do is I like to actually use my calculator to find the answers first, and then we are going to solve this algebraically. That way, as we go, if we make a mistake, we know because we have our answers ahead of time. Okay, so just to remind you how to do that, what we're going to do is on our calculator, we're going to hit second and see where it says matrix. We're going to hit matrix. We go over to edit and hit enter. Now, my matrix is set up as 1 by 1. Don't we have 3 equations, right? 1, 2, 3. And we have 4 columns, really. A column for the A, a column for the B, a column for the C's, and a column for the number. All right, so I'm going to set this as 3, enter, 4, enter, 3 by 4. And now if you remember, we just plug in our numbers. Since the number in front of the A is a 1, the B is a 4, in front of the C is a 6, and the number by itself is 23, we're going to type in our first row, 1, 4, 6, 23. So 1, 4, 6, 23. Okay, and so the next row would go 1, 2, 1, 2. All right, the next one would be negative 1, 6, 2, 14. So negative 1, 6, 2, 14. Okay, once we're done, we want to quit out of the screen. So we're going to hit second and mode. See, it says quit on top of that? All right, now we're going to go back to matrix for the second time. So second and then matrix. This time we go over to math. And you could scroll down, but it's faster to scroll up until you see RREF. See right there, it's letter B. Okay, then we have to tell it what matrix we want to use. So this is the final time we're going to go to matrix. So for the third and final time, we hit second, matrix. And on the first one, just hit enter. That's the one we created. That's what we want to use. And when you hit enter, these are our answers. Negative 3, 0.5 or 1/2, and 4. It goes right in order. See how we have A, B, C? A is negative 3, B is 1/2, and C is 4. Okay, so I just copied these right from the screen and I put them on my paper. That way, as I do the problem, I know if I'm on the right track or not. Okay, so let's do this. Now remember, we want to keep our work organized. So the first thing we do is we label our equations. I label them, I'm going to actually do it over here, A, B, and C. You could label them whatever you want. You could label them X, Y, Z. It totally doesn't matter. All right, now, there's a lot going on, so let's, keep our work organized. We're going to label this step 1. All right, so the first thing we want to do is we want to line up any 2 equations. It does not matter, but you're trying to cancel one of the variables. Now, what looks really easy to me, see how this is a negative A? And I mean, both of these have positive A's. So I'm going to line up one of these 2 equations with my C. Why don't I line up equation A and equation C? Okay, so there we have it. And sometimes if things don't so nicely just cancel out for you, you may have to multiply one of these equations by something, and that's okay. All right, but this one's nice and easy. The A's cancel, and when I combine my like terms, 4B plus 6B is 10B, 6C plus 2C is 8C, and 23 plus 14 is 37. Now, I'm going to need to use this equation, so I'm going to give it a label. I just go right in alphabetical order. I'm going to call that D. So I'm going to use equation D in a bit. Okay, now for step 2, what we want to do is we want to cancel out the same exact variable that we canceled in step 1. So see how in step 1 we canceled the A's? We have to cancel the A's again, okay? If not, you're not going to get anywhere. It's just going to be a wasted step. So remember how we said that equation B has a positive A and equation C has a negative A? That's a nice, easy way to get the A's to cancel again. So let's line up equation B and C. Okay, so there we go. So now, like we said, the A's are going to cancel and just combine your like terms. So 2B plus 6B is 8B. 1C plus 2C would be 3C. And then 2 plus 14 is 16. And I'm going to label this equation E. Okay, now let me come all the way over here and do step 3. Now, for step 3, we are going to use equations D and E. Okay, that's usually the process. Now, if we look at equation D and equation E, the B's don't cancel. Okay, the C's also don't cancel. So what's going to happen is we're going to need to multiply either one of these equations or both of these equations by a number in order to get something to cancel. Now, I'm actually going to choose to cancel the C's just because they're smaller numbers. All right, so let's look at what's in front of the C's. So this is an 8C, and this is a 3C. All right, well, I mean, if I were to, let's say, basically, I want to get one of these to be a positive and the other to be a negative of the same number. So let's just say I multiplied this, equation D, by positive 3. Wouldn't that be a positive 24C? So then I'd want a negative 24C here. So I can multiply this by negative 8. Okay? What you could really do is see this number right here in front of the C in equation E. Just put it right here in front of equation D. And see this number right here in front of the C in equation D. Just take that number and put it in front of equation E. And then just make one of them negative. I think I said I was going to make that one. Or actually, I don't even know which one I said, but I just chose to make that negative. So now what I want to do, some people like to write this out. Some people like to put negative 3 and then write out equation D and show you're distributing. If you like to do that, you can. I personally don't. I feel like there's enough going on in these problems, so to add more chaos to the paper, I don't like to do that, but some people do. I like to just take my finger and distribute to the equation we already have there. Okay, so let's do it. So negative 3 times 10b would be negative 30b. And just use your finger to distribute. Negative 3 times 8c is negative 24c. Let me bring down my equals. And negative 3 times positive 37 would be negative 111. Okay, now let's do the same thing with this 8. Let's distribute it to equation E. Okay, so 8 times 8b is positive 64b. 8 times 3c is positive 24c. Okay, and keep distributing. So 8 times 16 will be positive 128. Okay. Now, when we add these two equations together, this is where we should come up with the value of our first variable. All right, so we could see clearly right here that the c's cancel. And let's just combine our like terms. So negative 30 plus 64 is positive 34. So this would be positive 34b. And bring down the equals. Negative 111 plus 128 would be positive 17. Okay, and then when we divide both sides by 34 to get the b by itself, we wind up with b equals 1/2. Or 0.5, however you want to write that. So look at that. That matches up with what we had gotten in our calculator. And that's why we do it in the calculator first, to make ssure as you go, you're on the right track. Okay, you don't want to have to wait all the way to the end to check, because then you have to go back and, fix the lot. If we made a mistake here, we'd only have to look at these 3 steps. All right, so now let's go on to step 4. Now in step 4, we are also going to use either equation D or E. It's totally up to you. I'm going to use equation E, just, it's smaller numbers. So let me move this up a little. Okay, so using equation E. Now that we know what B is equal to, let's replace that 1/2 into equation E for the B, and then we'll be able to solve for C. All right, so instead of 8b, we're going to have 8 times 1/2. And then let's just bring down the rest of this equation. So plus 3c equals 16. Okay, so 8 times 1/2 is 4. So 4 plus 3c equals 16. So just solve this. Subtract 4 from both sides of the equation. So that gives us 3c equals 12. And when we divide by 3, we get c equals 4. All right, now, let me look back up. I have to move the screen up. And look at that. C does equal 4. Okay, so now we just have to show we're solving for A. And in order to do that, we have an A in any one of these 3 original equations. I'm going to use equation B. That one looks really nice and easy. A plus 2B plus C equals 2. Okay, so let me come down here. Step 5. And this is why you want to organize your work, because there's a lot of steps going on. So equation B had said, what did it say again? A plus 2B plus C equals 2, I believe. Let me just check. Yes, okay, that's what it says. So we know that B is 1/2, and we know that C is 4, so we're going to substitute them in for B and C. Okay, so let's do it. So A plus 2 times, we said B was 1/2, and then plus, we said C is 4. We could bring down the equals 2. So A plus, well, half of 2 is 1, right? 2 times 1/2 would be 1. And then I'll bring all this down. And if we combine our like terms right here, isn't 1 plus 4 just 5? So A plus 5 equals 2. And when we subtract 5 from both sides of the equation, we get A equals -3, which I believe that's what it said, but let's just double check. Yep, there it is. All right, so we wound up algebraically solving this system of equations. Okay, so number 5 actually is dealing with shifting functions. So I just put our basic shifts up here, okay? If you add a number to the end of a function, it shifts it up. If you subtract a number to the end of a function, it shifts it down. If you add a number within a function, it shifts it to the left. And if you subtract the number within a function, it moves it to the right. All right, so they give us this function right here. They call it the parent function. And they want to know which transformation describes what happens when we add A within the function, right, within the parentheses, and subtract B to the end of the function. Okay, so let's start with this. If we add a number within a function, see how we add a number within a function? It moves it to the left. So we're going to be going to the left A units. So far it's either choice 3 or 4. Okay, now if we subtract the number from the end of a function, see right here, it's moving it down. So we're going to be going down B units. So choice 4 is our answer. Okay, so number 6, they're talking about the numbers of hours of daylight on the first day of each month in Rochester. And it looks like down here they want us to find, I'm going to actually underline this, the average rate of, actually I'm boxing it off, change. Okay, so here's our average rate of change formula, so we know we're going to be using this. Now they want us to find the average rate of change in hours of daylight per month from January 1st, so this right here, until April 1st. So this right here. Okay, so we know that the first column represents our x values and the second column represents our y values. So I could see right here, this would be x1 and x2. So then this would be y1 and y2. Now, they do give us numbers for y1 and y2. They don't give us numbers for x1 and x2. But think about this logically, right? What number month is January? Isn't that the first month? And what number month is April? Isn't that our 4th month? So even though they don't come right out and give it to us, I mean, it's very clear what numbers to use for x1 and x2. All right, so let's plug those numbers into our formula right here. Okay, so I just took these numbers, right, y2 minus y1 over x2 minus x1 and plugged them in. All right, so if we subtract our numerators, that gives us, what, 4.5. And if we subtract our denominators, that gives us 3. And 4.5 divided by 3 simplifies to 1.5. And that would be, they give you the units right here, hours of daylight per month. And it makes sense, because think about it. Aren't these the y's on top, which is hours of daylight? And aren't these the x's on the bottom, which is months? And instead of writing out hours of daylight per month, if you prefer to do it like this, hours over months, that just means hours per month. I guess you could write it like that as well. Now, it does say to interpret what this means in the context of the problem. All right, well, since this is a positive number, what it means is the number of hours of daylight is increasing, right, because it's positive, by 1.5 hours per month, and you need to somewhere say on average. I like to kind of phrase that somewhere in the middle of the sentence. All right, so let me write that out. Okay, so I just said that the number of hours of daylight in Rochester, New York is increasing on average, remember that's really important, by 1.5 hours per month. And it's also important to state when it happens, because if we looked at the average rate of change, let's just say from January to May, or from February to December, like it would be totally different. So it's also important to say the interval we're looking at. Okay, so number 7, if f of x is an even function, which function must also be even? Now, I want to point out, they're not talking about an even degree function like x squared, x to the 4th. They're talking about an even function. And let me just remind you, okay? We'll do even and odd. An even function is a function that is symmetric to the y-axis. So what that means is, if I were to take, let me just draw an even function. Here we go. If I were to take my graph and fold along the y-axis, one half of the graph would fold directly on top of the other half of the graph. Now this is hand-drawn, so it's not perfect, but you could see that if this were like true out, graphed in a calculator, nice and neat, one half of my graph would fit directly on top of the other half if I did fold along this y-axis. So this is even. Not that we need it for this question, but reminder, an odd function is one, like, for example, again, this is hand-drawn, like this, where if I were to take my graph and rotate it 180 degrees, basically just take it and flip it upside down, it would look exactly the same. Okay, now, let's think about an even function. If we look at this function right here, okay, what you could see they're doing in the answer choices is they're shifting them all. And if you remember, that's why I put these up here, okay? If you remember, this is the way our shifts work. So think about it. Let's start with choice 1. If we take our graph, right, if you subtract a number within the parentheses, doesn't that mean we are moving it to the right? If I took this purple graph, let me make it in a different color, make it green, and moved it to the right, would that now be even? Would that be symmetric to the y-axis? Not at all, right? So choice 1 does not work. Okay, so let's go to choice 2. So, I mean, basically, if you move something left or right, it is not going to stay even. So if you look at choice 3 and choice 4, look, isn't that moving it to the left? And that's also moving it to the left. So, I mean, we can automatically eliminate choices 1, 3, and 4. So it's got to be choice 2. But let's see why it's choice 2. Choice 2 shows that we're taking a function and moving it up. Okay, we're moving it up 3 units. So if I were to take this purple graph and move it up 3 units, let's just say this is up 3 units, isn't that still even? If I were to fold along this y-axis, wouldn't one half of the graph fold directly on top of the other half of the graph? So choice 2 is our answer. Okay, number 8. So they give us, this symbol right here means the inverse. So they give us the inverse function, and they want to know which equation represents the original function f of x. So the long way would be to find the inverse of each of these one by one. The shortcut way would be, if you find the inverse of the inverse, it just brings you back to the original function. So let's just find the inverse of this. Now, we know whenever we see the inverse, all that's telling us to do is to switch the x and the y. Now, don't we know that this is just a fancy way of saying y equals? So we're going to make this an x, and then we're going to change this x to a y. And then all we want to do is get the y by itself in this equation. So let's first subtract the 2 from both sides of the equation. So these cancel, and that leaves me with, I mean, we can't combine these, right? They're not like terms. So we're going to leave that as x minus 2 equals negative 3/4 y. Now, normally when you want to get rid of a number that's being multiplied by a variable, we divide, because the opposite operation of multiplication is division. But I don't think I want to divide by a fraction. So what I can do instead is I can multiply by the reciprocal. The reciprocal means just flip it upside down. If it's negative, the reciprocal is negative. If it's positive, the reciprocal is positive. So the reciprocal of negative 3/4 would be negative 4/3. So I'm going to multiply both sides of the equation by negative 4/3. And the reason I do that is so I'm able to get the y by itself. Because look, isn't a negative times a negative positive? And wouldn't this 3 on top cancel with the 3 on bottom? And the 4 on top cancel with the 4 on bottom? So basically, a number times its reciprocal is 1. Okay, it cancels out, leaving us with 1y, or just y. And now I can distribute this negative 4/3 into the parentheses. So negative 4/3 times x is negative 4/3 x. And then negative 4/3 times negative 2. I'm going to make that a negative 2 over 1, right? Might as well make it into a fraction. Well, a negative times a negative is a positive. And then if we multiply our numerators, 4 times 2 is 8. And multiply the denominators, 3 times 1 is 3. Okay, and the only other thing they did in the answer choices was instead of using y equals, they put this back into function notation. So we're looking for which one says negative 4/3 x plus 8/3. So there we have it. Choice 2 is our answer. Okay, and then finally, number 9, they're talking about a parabola here whose focus is 4 and negative 3, and directrix is y equals negative 1. So, I mean, personally, I would first just plot this. So let's see, we have the focus is at 4, negative 3, so over 4, down 3. Okay, this is our focus. And the directrix is at y equals negative 1. So we can make a line right here at y equals, positive 1. I don't know why I said negative. All right, now we know if the directrix is up here and the focus, let me just label that F for focus, is down here, we know that not only is the vertex going to be in the middle of these two, but the parabola is going to open down. It's going to open away from the directrix. So we're going to be using this equation right here, the one that has the negative in front of it. Okay, so let's first figure out where the vertex is. So if this is at a height of 1 and this is down at negative 3, there's 4 units between them, right? You can count it if you have to. 1, 2, 3, 4. So half of 4 would be 2. So if I go 2 units up from the focus or 2 units down from the directrix, I will be at my vertex. And the coordinates of the vertex are important. So let's write the coordinates of that on the point. So we went over 4 and down 1. So 4, negative 1. Okay, and again, our parabola is opening away from the directrix, so it's opening down. Okay, so let's fill in our equation right here. So we'll have y equals negative 1 over 4 times p. Now, if you forget what p is the distance between the vertex and the focus, which is also the distance between the vertex and the directrix. So we said that was 2 units. So isn't 4 times 2? Sorry, I'm looking at this equation. Isn't 4 times 2 just 8? So I'm going to make that an 8 down there. Okay, then it's x minus. Now, h and k. These are just the coordinates of our vertex, right? So the h we get from right here, and the k we get from right here. So I'm going to just fill them in our equation. So it's going to be x minus h, so x minus 4. And then close your parentheses and square it. Now, instead of writing plus negative 1, isn't plus negative 1 just minus 1? So there is our equation. Now, if you look at the answer choices, none of these look exactly like I have here. But it looks like what they did in the answer choices was they got the term, the parenthesis with the square on it, all by itself. Now, I could tell right off the bat, we have an x minus 4 squared. This is the only one that has an x minus 4 squared. So choice 4 has to be the answer. But let's just show, just in case there was other choices, for a different question, how we get this by itself. Okay, so I'm first going to add 1 to both sides of the equation, which would leave me with y plus 1 equals negative 1/8 times x minus 4 squared. Right, these cancel. And then to get rid of the negative 1/8, right, to get this by itself, I'm going to multiply both sides by the reciprocal of this. So the reciprocal would be, I'll just put it over here, negative 8 over 1, which is really just negative 8. I mean, if you prefer to just write, look, negative 8, you can do that. But anyway, the negative 1/8 and the negative 8 over 1, its reciprocal cancels off. So it leaves us with, I'm not going to distribute this. I'm going to leave this as negative 8 times y plus 1 equals, and then I'll bring down the x minus 4 squared. And the reason I didn't distribute this was because they didn't here. Okay, so choice 4 is our answer.